The main factor that contributes to the success of a precast building project is integration of all building professionals. Professionals stated here include architects, engineers, clients, contractors, and subcontractors. The involvement of all players at an early stage is critical to a precast project. Today, the fragmentation approach towards design and construction among the professionals within a project is evident in most projects. A shift in paradigm is crucial to achieve success in any project. This section attempts to provide a guide for the construction of a precast project. The reader should define the contents by consultation with professionals and precasters.
Construction considerations. The contractor should consider the following: all safety issues on site when handling precast elements, especially so when working within a tight site. The lifting capacity of the crane used, the working boom radius of the crane, the suitability of construction materials for the purpose of use, in example, sealant grouting, shim plate, and propping. Coordination with the precasters and specialist suppliers to achieve the best performance and working method. Precasters often provide relevant technical requirements to the contractor during the design development phase to avoid discrepancy. Precast walls are propped before casting of joints. Proper planning is required for perfect alignment. The pore strip between two pieces of precast walls are cast. Precast planks are installed in place. Preparation for precast of landing slab and precast stairs. Preparation of welded mesh and services for the cast-ins. Preparation of welded mesh and services for casting in situ topping. Concreting of topping.
The sequence of work shall be the following. First, a quick check to ensure that the correct panel is used before hoisting. Next, the crane lifting capacity must be ensured before hoisting the panel. Ensure that the crane's working radius is the desired one. Ensure that the anchorage for the propping does not damage the cast-in building services. Ensure that the desired reduced level of panel base is achieved by adjusting the shim plate. The shim plate should be at an interval of 500 millimeters. Ensure that the desired verticality or position is achieved. The total estimate time to install a typical precast element is at least half an hour to 3/4 of an hour. The construction requirements are the following. Elements of control, meaning alignment, verticality, and levels. Tolerance level. For the wall, the vertical deviation must be plus 2 millimeters. For the wall, the vertical deviation must be positive 2 millimeters or negative 2 millimeters. Horizontal deviation must be 0 millimeters. For the beam and slab, departure from the intended horizontal position must be positive 2 millimeters or negative 2 millimeters. Departure from the vertical position must be positive 2 millimeters or negative 2 millimeters. The following diagrams illustrate the sequence of installation for the precast beam and slab system. First, setting out. The surveyor must set the cross reference. Transfer the grid and mark the wall position on the slab. Mark the 100 millimeter offset line from rear building edge. Offset the wall position by 200 millimeters. And finally, secure 2x2 timber to the floor at wall edge to guide wall. Wall positioning. The first wall in place has to be the partition wall at the rear. Mark a line parallel to and 100 millimeters from the external edge of the wall. Place the shim plate on the floor and level
Precaution. Specify items which cannot be compromised. Zero tolerance on partition walls, dividing boundary line between units, external building lines, staircase dimensions, HS internal dimensions. Alignment priority. Alignment of grooves, uniformity of grooves, horizontality of architectural treatment. Post-installation. Number 1. Verify alignment and verticality of every wall. Number 2. Verify cast slabs level at 1 meter grid. Number 3. Report deviation and rectify if required. Constraints and solutions. Access. Constraint. Small road in front of site may not allow crane and delivery trailers up to 3.5 meters wide to park. Solution. Use smaller crane and trailers to deliver and install small components. Constraint. Crane and trailer are unable to negotiate small turning radius at junctions and small roads. Solution. Study the locality and look for unavailable spaces for turning. Have one worker direct traffic while crane and trailer is turning. Constraint. Diversion of existing services such as lamp posts, fire hydrants, and overhead electrical cables may be necessary. Solution. Diversion must be done before installation of precast components begin. Constraint. Existing trees and shrubs in front of site require National Parks Board's approval before they can be removed and later reinstalled. Solution. The consultants must write in to National Park Board for approval much earlier before construction begins. Crane capacity and reach. Constraint. Lifting capacity of small crane not enough to lift heavy and far components. Solution. Hire bigger cranes with longer boom to lift heavy and far components. Alternatively, plan the sequence such that the crane can park nearer to heavier components. Coordination. Constraint. Wrong components delivered to site. Solution. Provide clear labels on components and drawings to avoid confusion. Constraint. Wrong sequence of delivery, such as planks arrive first before the beams on the same day. Solution. Person ordering must maintain good communication with person delivering. Installation. Constraint. Lifting over neighbor's roof may cause anxiety over safety and damage to existing properties. Solution. Crane and trailer can be parked strategically to avoid such lifting. Crane operator can make use of boom angle to keep lifting within site boundary. Constraint. Starter bars do not match with grouting holes or clashing of bars at connections between beams and columns. Solutions. Equipment and workers to crank or bend the starter bars will be provided on site. Handling. Constraint. Damage such as cracks and corners chipped off occur due to knocking during handling. Solution. If damage is minor, cracked components can be repaired using approved epoxy resin. Not shrinking grout can be used for chipped off corners.